Solve the equation using the quadratic formula. So here we have our equation. There's a 1 in front of this x squared, so that a is 1, b is negative 4, c is negative 1. Here's the quadratic formula. Plug everything in. Negative b is negative 4, b is negative 4, goes right there. Minus 4a is 1, and c is negative 1. And 2a right there. So I simplify that down, simplify that inside there. You get 16 plus 4. And here, the negative of negative 4 is positive 4. 2 times 1 is 2. Come down here. 4 plus or minus 16 plus 4 is 20 divided by 2, and the square root of 20 is square root of 4 times 5, and radical rules from algebra 1 say that you can break up that multiplication, square root of a multiplication, into the multiplication of the square roots. That doesn't work for that addition though. But anyway, square root of 4 is 2, square root of 5, so that's 2 square root of 5, which we put right there. Then I realized that 2 is going to be able to divide into both of those, so I broke it up into here and here. 2 goes into both. And then 4 divided by 2 is 2. 2 divided by 2 is 1. So here you have this, and then you write them separately. X is 2 plus square root of 5, or x is 2 minus square root of 5. So there's a solution set. Now, since the solutions are irrational, because they have the square roots in them, that means the original quadratic polynomial on the left side cannot be factored with integer coefficients. In other words, you can't factor it over the number systems that we usually factor these over. And let's just show that. For x squared minus 4x minus 1, x goes here, x goes here, 1 would have to go there, and 1 would have to go there. And there's no way that 1x and 1x can combine to be negative 4x. Impossible. So that's not going to factor. Now let's check this result with the calculator. The two roots are here. 2 minus square root of 5 on the calculator is this decimal. 2 plus square root of 5 is this decimal. Let's graph a function f of x equals x squared minus 4x minus 1. Graphs like this, we're looking for these two roots. You can see they don't cross at any exact integer value, but we'll find out. So we do a second calc 0 and find the left one, and it's negative 0.236068, which is this one right here. So that checks out. And then the one on the right, 4.236068, that's this one. Those two check out. So it verifies. Here's another problem. 2x squared minus 7x minus 15 equals 0. This time a is 2, b is negative 7, c is negative 15. And there's the quadratic formula. Negative negative b, there, b squared minus 4ac, all over 2a. Work on that. Minus of a minus 7 is a 7. Negative 7 squared, 49. Here is 30 times 4. Subtraction of a negative is a positive. So it's 120. Add those together, 169. Square root of 169 is 13. So x is 7 plus 13 over 4, or x is 7 minus 13 over 4. So this reduces down to 20 over 4, which is 5. This one is negative 6 over 4, which is negative 3 halves. So Here's the solution set listed that way. So since solutions are rational, that means the original quadratic polynomial on the left side of the equation can be factored with integer coefficients. So let's show that it does. Here's the original polynomial. So we have 2x and x. 15 is 3 and 5, or 15 and 1. If you put the 3 here and a 5 here with a minus and a plus, it works out. You can check the middle term. It verifies.